The Tiny Universe Inside, An Atomic Adventure. Written by Brian Cox, BBC. Everything around us, from the chair you're sitting on to the air you breathe, is made of tiny particles called atoms. These atoms are the fundamental building blocks of all matter, the very essence of what makes up the universe. Imagine, every object you touch, every breath you take, is composed of these minuscule entities. These atoms are so small that millions of them can fit on the period at the end of this sentence. To put it into perspective, if you were to line up atoms side by side, it would take about 500 million of them to span the width of a single human hair. Their size is truly mind-boggling. The idea of atoms has been around for a long time. Ancient civilizations pondered the nature of matter and the universe. They sought to understand what everything was made of, leading to early theories and philosophical musings about the smallest components of the world. An Indian philosopher named Maharishi Kannada proposed the idea of indivisible particles over 2,500 years ago. His insights were revolutionary for the time, suggesting that everything in the universe was composed of these tiny, indestructible units. Since then, scientists have been on an incredible journey to uncover the secrets of these building blocks of matter. From the early alchemists who tried to transform base metals into gold, to the modern physicists who smash particles together at near light speeds, the quest to understand atoms has driven scientific progress. This journey has taken us from ancient philosophers to modern laboratories with powerful microscopes. These advanced tools allow us to see and manipulate atoms in ways that were once thought impossible. The evolution of scientific thought and technology has opened up new realms of discovery. Along the way, we've learned that atoms are not the smallest particles after all. Within each atom lies a complex structure of even tinier particles. These subatomic particles include protons, neutrons, and electrons, each playing a crucial role in the behavior and properties of the atom. They are made up of even tinier particles called subatomic particles. Protons and neutrons reside in the nucleus at the center of the atom, while electrons orbit around this nucleus, creating a dynamic and intricate system. The interactions between these particles govern the chemical and physical properties of all matter. In this essay, we're going to dive into the fascinating world of atoms, exploring their structure and how they combine to form everything we see around us. We'll look at how atoms bond together to create molecules, the building blocks of more complex substances. From the simplest hydrogen atom to the most complex organic compounds, the diversity of atomic combinations is astounding. Get ready for an adventure into the tiny universe inside. We'll uncover the mysteries of atomic interactions, the forces that hold them together, and the incredible ways they come together to form the world we live in. This journey will not only deepen your understanding of science, but also ignite your curiosity about the unseen wonders that make up our reality. Building blocks of matter. Meet the subatomic trio. Atoms are made up of three fundamental particles: protons, neutrons, and electrons. Think of them as the Lego bricks of the universe. Protons are positively charged particles. They have a +1 charge. Neutrons, on the other hand, have no charge. They are neutral. These two particles reside in the atom's central core, which we call the nucleus. Electrons are much smaller than protons and neutrons. They are negatively charged particles with a -1 charge. They are always on the move, buzzing around the nucleus in a region called the electron cloud. The atom's heart nucleus and its electron cloud. Imagine the atom as a miniature solar system. At the center of this system is the nucleus, which is like our sun. The nucleus is tiny compared to the whole atom, but it contains almost all of the atom's mass. Why? Because protons and neutrons are much heavier than electrons. The electrons are like the planets orbiting the sun. They are constantly moving around the nucleus at incredibly high speeds. The region where electrons are most likely to be found is called the electron cloud. This cloud is not a solid object. It's more like a fuzzy region where electrons zip around in unpredictable patterns. Atomic identity card. Number and mass. Every atom has an identity card. This card tells us two important things about the atom: its atomic number and its mass number. The atomic number is like the atom's fingerprint. It tells us the number of protons in the atom's nucleus. Every element has a unique atomic number. For example, hydrogen, the simplest element, has an atomic number of 1, meaning it has 1 proton in its nucleus. The mass number, on the other hand, tells us the total number of protons and neutrons in the nucleus. Since protons and neutrons have almost the same mass, the mass number gives us a good idea of how heavy an atom is. Atomic bonding. How atoms make friends. Atoms are social creatures. They like to interact with each other. In fact, most atoms are more stable when they are bonded to other atoms. They achieve this by sharing or transferring electrons with each other. This process of electron sharing or transfer is called chemical bonding. There are different types of chemical bonds, but they all involve the interaction of electrons in the outermost shell of the atoms involved. Imagine atoms holding hands with each other. That's kind of what happens when they form bonds. From Canada to now, a journey of discovery. The story of the atom is a tale of human curiosity and relentless pursuit of knowledge. Our understanding of the atom has come a long way since Maharishi Kannada first proposed the idea of indivisible particles. In ancient India, Kannada's vision laid the foundation for what would become a cornerstone of modern science. Over centuries, scientists have built upon each other's work, refining and expanding our knowledge of these fundamental building blocks of matter. Each generation of scientists has added a piece to the puzzle, from the alchemists of the Middle Ages to the pioneers of the scientific revolution. From the discovery of the electron in 1897 by J.J. Thomson, which revealed that atoms were not indivisible after all, to the development of quantum mechanics in the 20th century, spearheaded by brilliant minds like Albert Einstein and Niels Bohr, each new discovery has brought us closer to understanding the intricate workings of the atom. The atomic models evolved from simple spheres to complex structures, reflecting our growing comprehension. Today, powerful microscopes allow us to see individual atoms and even manipulate them. These advancements have opened up new possibilities in fields like nanotechnology and material science. This journey of discovery is far from over. As we continue to push the boundaries of what we know, we uncover more questions and challenges. Scientists are still working to unravel the mysteries of the atom, delving deeper into its structure and behavior. The quest to understand the atom is a never-ending adventure. Exploring the strange and wonderful world of quantum mechanics, researchers are constantly surprised by the counterintuitive nature of the quantum realm and searching for new particles that might be hiding within the atom's core. The discovery of these particles could revolutionize our understanding of the universe and lead to groundbreaking technologies. Conclusion: the unending quest to understand. The atom is a microcosm of the universe, a tiny world full of wonder and complexity. It represents the fundamental building blocks of everything we see around us, from the smallest grain of sand to the vastness of the cosmos. Each atom holds within it the secrets of the universe, waiting to be unlocked by curious minds. From the ancient philosophers who first imagined the idea of atoms, like Democritus, who proposed that everything is composed of indivisible units, to the scholars who debated and refined these ideas over centuries, to the modern scientists who study them with the most advanced tools, such as electron microscopes and particle accelerators, our understanding of the atom has evolved dramatically. These tools allow us to peer into the very heart of matter, revealing structures and behaviors that were once beyond our wildest dreams. Our quest to understand the atom has been a journey of incredible discovery. From the early experiments of pioneers like Rutherford and Bohr, who uncovered the nucleus and the electron orbits, to the groundbreaking work of contemporary physicists exploring quantum mechanics and particle physics. And this journey is far from over. Each discovery opens up new questions and new avenues of research. The more we learn, the more we realize how much we still don't know. As we delve deeper into the atom's secrets, we uncover layers of complexity that challenge our understanding and push the boundaries of science. The atom is not just a particle, it is a gateway to understanding the fundamental forces of nature. We continue to uncover new mysteries, such as the behavior of subatomic particles and the interactions that govern their movements. Each piece of data, each experiment brings us closer to a more complete picture of the universe. And as we push the boundaries of our understanding of the universe and our place in it, we also push the boundaries of technology and innovation. The quest to understand the atom has led to advancements in medicine, energy, and materials science, impacting our daily lives in ways we might not even realize. The atom, once thought to be the smallest indivisible particle, is now understood to be a complex structure made up of even smaller particles like quarks and gluons. This realization has opened up a whole new field of study known as particle physics. The atom is now a gateway to a universe of possibilities, a constant reminder that the more we learn, the more we realize how much more there is to know. It challenges us to keep questioning, keep exploring, and keep pushing the limits of our knowledge. A constant reminder that the more we learn, the more we realize how much more there is to know. Each discovery is a stepping stone, leading us to new questions and new horizons. The unending quest to understand the atom is a testament to human curiosity and ingenuity. It is a journey that will continue to inspire and challenge us for generations to come as we strive to unlock the mysteries of the universe and our place within it.